Previously, we looked at root locus, and we got to this graph. We said we want something, we are looking for something, some result that shows me graphically how poles are going to move if I increase some unknown number, some unknown parameter in my system. So let's develop main ideas behind root locus. Let's imagine we have a generic system. So we have G here, we have K, so H, G and K. K is my unknown number, it's just a parameter, I don't know the number of. G is known, I have the transfer function for it, and H is known too, I have the transfer function for it. So if I told you, if I asked you to determine the stability of this system, what would you do? Well, you write down the closed loop system's transfer function. It's K times G divided by 1 plus K times G times H. And you would tell me, well, if I want to have stability, I need to look at the poles, which means that I need to look at the denominator here. So I put 1 plus K times G times H equal to 0, which means that G times H times K should be negative 1, right? So to find poles of this system, I can solve this and basically make the denominator equal to 0, and that would be the poles of the system or roots of the denominator, and that would tell me stability. Now notice that this, I don't have G and H right now written. This is a symbolic equation, but what I know is that those are both functions of S, and S is a complex number. So I have a complex equation here that I want to solve. Remember, if for a second imagine, rather than having K times G times H, if I had some unknown real number X, if I had 1 plus X equals to 0. Okay, 1 plus X equals to 0 means that X is equal to negative 1. Okay, for real numbers, that is easy to solve. If I have 1 plus X equals to 0, X is negative 1. And so I can just tell my number is negative 1. But if X is a complex number, 1 plus a complex number being 0 gives me more information. X equals to negative 1 means that X is a vector with magnitude of 1 and angle of 180 degrees. Okay, if you don't remember that, you should go look it up. Remember what complex numbers were. So having equation 2 tells me that K times G times H, because it's a complex number, has magnitude of 1 and has angle of plus minus 180 degrees to n plus 1 when n is 0, 1, or 2. What does this mean? Well, plug in these values of n and see what you get. N equals to 0, I'm going to have plus minus 180. N equals to 1, I'm going to have 180 times 3. If I put 2 here, I'm going to have plus minus 180 times 5. So what does that mean? Well, what that means is that my angle that has resulted negative 1 can be 180 degrees, can be negative 180 degrees, can be 180 degrees plus 360, can be negative 180 degrees, negative 360. And then you can just add or subtract 360 degrees again and again, and it all would give you the same results. So that's the complex number and how we analyze complex numbers. Okay, so get back to this result we got here. I wanted to find the poles of the system. Therefore, I said the denominator should be 0. Brought this 1 to the other side. I got negative 1. Remember that this is a complex number, therefore it has a magnitude and an angle. what this result tells me is that every point on the S-plane or phase plane that satisfies this equation is part of the root locus. Again, every point in the phase plane that satisfies this equation is part of the root locus. What do I mean by that? Let me go back and find the numerical example. Here, what did I do if I had k equals to 0? I simply put the denominator equal to 0, and I said that would, if I solve that, that tells me s is equal to -1 and -3. What that means is that if I plug in -1 and -3 into this equation when k is equal to 0, that would make the denominator of this equation, of this new fraction 0, right? So if I rather than solving it like this, numerically, just create 1 billion values for s and just try all of them inside this equation, none of them make the denominator 0 except s equals to -1 and -3, right? You just plug in all the numbers in the world, only -1 and -3 make this equation equal to 0. So if I look at the entire map, imagine the 2D map, and if I try all the numbers, all the different locations on the phase plane, inside this equation, only s equals to -1 and -3 would make the denominator 0. Okay. So now you're trying to do the same thing. You're saying if you want this denominator to be 0, you can use different values of s, right? You can plug in different values of s. Doesn't matter what you use. If you want the denominator to be 0, that means that this term should be -1, which means that the magnitude of it should be 1 and the angle of it should be positive -180 degrees. Let's see an example. I'm given this g here, I don't have k, and I'm being asked, is the point s equals to -10 plus j 9.055 in the root locus? For what value of k? Okay, so I'm given g and I have h here is 1 and I have negative feedback. If I substitute the given value of s inside of it, so s is given to me, I'm going to get this complex number, and I want to find whether or not this complex number satisfies my condition here. So the angle of it should be plus minus 180 degrees. Is the angle of this number 180 degrees or negative 180 degrees? Well, remember, for complex numbers, if I have a fraction, the angle of that fraction is the angle of the numerator minus the angle of the denominator. If I have multiplication of two numbers, the angle would be the angle of the first plus the angle of the second. So the angle of the numerator here, what would that be? The angle of the numerator is just 90 degrees. What's the angle of this, or the angle of this? Well, I have, for the entire fraction, the angle of the numerator minus the angle of the denominator, which I can multiply whatever is inside the denominator and get this. And the angle of the numerator is 90 degrees, and then angle of the denominator is 180 minus tangent inverse of 10.055 divided by 9. And these two simplify. The angle of the entire thing is negative 180 degrees. Therefore, it satisfies this condition. How about the first condition? By the way, if you don't remember how to do these mathematics, you should go look it up. Okay? So there's a link provided. here, this is the link. You go click on it, go read about complex algebra. So the given point in the S-plane satisfies this condition. How about the first condition? Well, I don't know K, right? So basically, I can find that value of K if I find the amplitude of G times H. I can find the corresponding K, which makes this entire thing, uh, 1. So if I want K times G times H to be 1, I can substitute S and find the corresponding K, which in this example, it's going to be 18. What that tells me is that if I'm given a problem like this, I never really need to check the first condition because I don't know K. So I can find some K that satisfies this condition. The only condition I need to actually check is the second condition. And that is the base for root locus. So we only need to check the phase condition. What we only need to check is that the angle of G times H is 180 degrees times 2n plus 1. Okay. So that gives us root locus.